Okay, so what's coming up is, so today's a regular lecture, tomorrow a regular lecture, quiz on Monday. For most of you, it will be assigned during our class time, where you can start at the beginning and you just have to get it to me by the end of the class. But if you're in a different time zone, send me an email to let me know that you can't take it at that time, and I'll set up a different time for you. I can set up different times on Blackboard, so it's released at different times. Also, if you are having trouble uploading it next Monday, don't worry about it. Just instead of uploading it through Blackboard, you can just send me an email. So if you have trouble with uploading on Blackboard, send me an email. I will open up the mock quiz again on Friday if you want to try that again. Nothing new. It'll be the same as what you've already done. I think there were 12 people who tried it yesterday, and I was able to read all of them. So it seems to be working for the people who tried. Okay, so the review for next Monday for the quiz is the same review as the review for the quiz that we were going to have last Thursday, except for the question from 3.3. So let me actually start with a few examples of those, because we don't have too many homeworks, so let me just make up a few. Also, I should say, last Thursday when I was doing this, every once in a while my audio would go out. So if you can't hear anything, send me a chat message, and I'll stop for a minute. Hopefully I'll come back. I also have a microphone, but when I tried it last week, it didn't really work any better, so wait until something goes wrong. Yeah. So here is a vector function in terms of position. And let me ask the main question, which is, let's find the distance traveled between two times. So for this, what do I need to get the distance traveled? So I have the position function to get the distance traveled, and here I'm being a little lazy. I really mean total distance traveled, because we also have displacement, which we'll get to in a second. So what do I need to get the total distance traveled? Yes, so someone said velocity, so we need velocity. So I think I said this last Thursday. In some ways, this is a check. Do you remember your Calc 1 stuff, which is derivatives? So we have to take the derivative of the position function, and that will be term by term. So the derivative of e to the t squared. So checking to see if you remember your chain rule. So the derivative of e to the something is itself times the derivative of something. Take the derivative, middle one, easy one. And what do I need for the derivative of the third term? And product rule, yep. And so therefore I'll take the derivative of t, leave sine alone, leave t alone, take the derivative of up. So there's the velocity. And then similar to 3.1, distance traveled is the speed over the given interval. And in 3.1, you read this as absolute value, so you have to find where the velocity function is 0 and break up the integral. For this one instead, this is now the magnitude of the vector, and this is where it gets difficult to ask questions, but the magnitude of a vector is the usual Pythagorean theorem. Which is the square root of the sum of the squares. Since I just made up a function here to check your ability to take derivatives, we're not getting something that we can actually take the integral for. So therefore, if I gave a question like this on the quiz, that would be your final answer. And as with earlier stuff, once you get an answer, once you've done all the preliminary work, such as taking the derivative, you don't have to simplify. So you can leave it just like that. So as with last week, the problem with this is I'm now going to have to erase and then go to the next problem. So let me ask, are there any questions on this? This is kind of the basic part. Actually, I forgot one thing, which is I'm not going to write it down, but actually I can. I do have just enough room. If instead, let me call it part B. If I want to find the displacement from t equals 0 to t equals 1, what do I do? This is the easy one. Do I have to take the derivative? Yes. No. Yeah, so I forgot that, like last week, there's going to be lag, so I'll have to give you time to answer questions. So a few people put in, I would just plug in the two values and then subtract. So here it's nothing nice. X of 1 is e to the 1 and 2 and 1 sine of 1. And x of 0 is 1, 0, and 0. And then you subtract and you get back a vector function. So something like that. In some ways, I'm not too worried about the number. It should be okay, but you should double check. So the displacement is really easy if you're given this. If you're given velocity, you'll have to take the antiderivative to get the position first. But notice that your answer is a vector. So any question on either of these parts before I do another example where we can actually do the antiderivative of the total distance? Okay, so we erase. I should say I probably will not give one where you actually have to work it out for the quiz, because that will make it longer. And for the quiz, I want to keep nice short questions. So here, I give you the velocity. That way, if you can't mess up the derivative because you have to take it. So you're given the velocity. Let's again find the distance. And again, integral of the speed. And again, like the last one, its magnitude, which is the square root of the sum of the squares. Well, sorry. I was going to put them together, but then forgot I can't just erase a little piece. So I get the t squared plus 4t squared plus t to the fourth. Obviously, I can combine the t squared and the 4t squared. But also, you can see that I can factor out a t squared. And since that's a squared, I can pull it outside the square root. Sorry about that. And I get that. And this integral I can do. How would I do the antiderivative of this? And I'll see if I actually have enough space to do it. So what method? Now it's supposed to be inside the square root, just 5 plus t squared. For some reason I'm writing a 1. So what method do I use to do this antiderivative? Yep, so someone says use substitution, and this is what I at the beginning called the obvious one, because as someone said, we have the obvious function, and we have its derivative, so it works. I'll leave off the limits for now. And so we don't have the 2, so I'll divide through by it. I'll rewrite the square root. And I get that. As I said, I'll leave off the limits until we take the antiderivative. But if you want, you could get the full substitution when t is equal to 0, u is equal to 5. When t is equal to 1, u is equal to 6. So I can make those the new limits. Take the antiderivative. Again, leaving off limits, which is the u to the 1/2 plus 1 divided by the 3/2, which is multiplied by 2/3. So the 2's will cancel. Did I get that? Not very nice numbers, but not very difficult. So when I put in 1, I get 6. And whatever 6 to the 3/2 is, you can either leave it like that or throw it into a calculator. And if I put in 0, I get 5. So minus the 5 to the 3/2. I think I did it for my notes, and I have that as that. But either of those 2 last ones would be okay as an answer for a quiz. So you can see I kind of have to be careful in making it up so you can actually do the antiderivative. But since that makes it longer for the quiz, someone just asked me, just as I was going to say it, is for the quiz, I will just have you set it up. So more like this example than this one. So any questions on this? Because obviously something like this, where you do have to work it out, could be on the test. But we'll get to that later. So any questions on this before I erase? Okay, let me erase and do one more example. Because we have a variation. which is arc length. So in the previous two examples, we have functions in terms of t, so we can talk about velocity and position along the curve. Here we just have a curve, and I want to know, if I draw that, how long is that little arc? And we did this quickly, I forget, last Wednesday, last Thursday, and we noted that if we want to, and that's supposed to be a t, an x cubed, so let me make it more obvious here. I can make it into a vector function where all I do is let x be t and y be the function of x. And now you can see it's the same as before, and the only thing is that arc length is the same as distance. But you don't have to remember it that way. You can just remember this idea. Gives us this formula. Because if you look at the line above what I just wrote, if I take the derivative of the first entry, 1, and the derivative of the second entry is the derivative of the function, and then when I put it in, where I do the square of the sum of the squares, I get what I just wrote. So if you want, you can remember it as a separate formula for arc length, but it really is the same formula. And again, I can use this to check to see if you remember your derivatives. This one I made easy. So I just put in the derivative. And again, like the first one, that's as far as we can easily go, and that's as far as you would have to go on quiz if I put it on. So really the same thing. This is the other type of problem from 3.3. In theory, there's no reason it has to be y in terms of x. It could be x in terms of y, and it works the same way. So any questions on this? Okay. So this is as far as the quiz goes. So the quiz, so as they're saying it. So this is as far as the quiz goes. The test will go further because I think I said in the one announcement that the test will be in 2 weeks. And so tomorrow, Monday, I'll figure out when that might be because I'm waiting to see where people will be. I assume some people are still traveling today. So I'll wait a bit, find when people have a test and set up when the test will be. So this is as far as the quiz will go. And as I said, this is the only thing that is on the quiz that wasn't on the mock quiz. So the mock quiz had the radius of convergence one with the interval of convergence. There will be one of those, and then there will be one or two, probably two, of these displacement distance questions. So that will be the quiz. So before I move on to the stuff that isn't on the quiz, any questions on material that's on the quiz? Okay, so let me erase. And this is where my drawing ability is going to go badly, like on Thursday. So someone just asked, is the quiz just 3.3? And the answer is no. The quiz is, so here I'm going to write it, and then I'll erase it and go back to what I started here. So quiz is on 4.5, which is the last problem on the mock quiz, which is here's a power series and infinite series. Find the radius convergence, find the interval convergence. 3.1 is displacement total distance, but for one dimension. So try. This is now with a separate microphone. Does that work? So can anyone not hear me? That's probably easier. Okay. All right. So let me say again. So someone asked about what was on the quiz. So the quiz will be on the 3 sections 4.5, which is power series, where you get both one on the total distance, but in one dimension. Oh no, someone's losing again. So it doesn't matter which one I'm using. It must be just the connection. So try that. For some reason, it turned the audio off. Can you hear me? Okay. So last Thursday, we did one of these. I will do it around the x-axis and then parallel, and then we'll go into y-axis. So this is where my drawing ability is bad. So let me draw this. So this I'm okay with. So this is the region we're going to rotate. And not going to draw the three-dimensional one, but make that into an actual solid as we rotate it around. And as we did last week, I'm going to make a cut at X. And if I take that cut and rotate it, I'm going to get a washer, an empty space in the middle, and then the solid. And to get the volume, we're going to get the cross-sectional area. And if we integrate the cross-sectional area, we'll get the volume. Obviously, these are circles, so we need radiuses. And you can see R1 is just the distance from the x-axis to the bottom of the figure. And R2 will be the distance from the x-axis to the top of the curve. So R1 will be the easy one. What is R1? And R2 is equal to y, which means in this case it is the function. So I get this. Now, so I can try to keep it on the same page. Sorry about the mess. We now need the area. So obviously the area of a circle is the pi r squared. So we're going to do the area of the big circle minus the area of the small circle. So that's the area cross section at X. And we knew from Thursday that the volume is equal to the integral of the cross-sectional area. And let's see if I can fit it. Oh, I should put in that this is the point. Obviously, when y is equal to 1, that is x equals 2. So it's 0.21. So therefore, we're going to go from 0 to 2. And we'll get the cross-sectional area. And I'll just simplify the pi times 1 to pi. Usually, we'll just have you set up. So I use we because that means on the final this would also be true. You can see this actually isn't a bad integral, but for whatever reason, we just usually have you set up. So there's the base one. And now what I'll do is do the same picture, except now rotate it around something that is parallel to the x-axis, such as x equals y equals -3 or something like that. So someone asks, how do I know it's a washer? So the idea is for this one, it will always be a washer. Because if you look at it, I'm not drawing it well because I can't do three-dimensional graphs. But if I actually drew this as a three-dimensional object, you could see that the cross-sectional is going to be circles always, pretty much by design. And we just have an empty space in the middle, which is also a circle. So we're always going to get this type of cross-section. This cross-section will always be what it looks like if we're multiplying, ring around the x-axis or something parallel. When we rotate around the y-axis, in some ways it will look the same, but we'll deal with a different way. So we'll come to that. So any other questions on this setup? So someone asked, if you didn't give a y value, so if it was just the region between the x-axis and y equals 5 minus x squared, then yes, it would just be pi times the 5 minus x squared squared. Later, probably tomorrow, do one where it's between two graphs. So the general thing will be it's pi of the bigger curve minus squared minus pi of the smaller curve squared. So we'll come back to that. So any other questions on this one? It's only erase, do variation. So not to scale. Okay, so these two distances should be the same. So the only difference between this and the last one is now we're rotating them further away, which means it's going to be a wider thing. And when I look at our radius, we're now going to be measuring from here. And so therefore, we'll still get the same circle. It's just now, this will be our radius 1. And this will be our radius 2. So the area will still be the same. We'll still get the washer, so I won't draw it again, but the same picture as the last one. And we'll still get that the area of a circle is pi r squared. So the only thing that has changed is the radius. And let me start with, even though I wrote it like this, let me start with the inner one. What is R1 now? In the last one, R1 was 1. Now what is the distance from the negative 3 to 1? And seen a couple 4. So that would be just the 4. So I've just added 3 to the radius, which means what is going to be inside that first part? Inside the first parentheses. So we're going to, one says easier to write y plus 3. So therefore, it's only actually read like that. And therefore, we'll get, again, the integral from 0 to 2 because the picture is the same. It's still going from x equals 0 to x equals 2. And now y was 5 minus x squared. So I'll leave it like that. Just to remind you that once you get an answer, you don't have to simplify things. So obviously, that's 8 minus x squared quantity squared and 16 pi, but you can leave it like that. Okay. And again, I would just have you set up. So the only thing that's changed is r, and we know the formula for area is pi r squared, so that changes. Oh, so someone answered for me. So one person asked where does the y plus 3 come from? So that is r2. Because that distance, the distance, oops, it's supposed to go from the x-axis. The distance from the x-axis to the top of the curve is y. And then we've added 3 to the radius. So same as the last one. Okay, so now I'll follow up this up with same type of thing, except instead of rotating from further below, rotate from above. We did this also Thursday. So any questions on this before I erase? So you can leave the, so if you want, you can factor out the pi and bring it outside the integral, and that would be fine. Where did the 4? Oh, so the 4 was R1, and you can see R1 is, let me make it more obvious there, is this distance, which is 3, and this distance, which is 1, because we're going up to the line y equals 1. So it's the distance from y equals 1 to y equals negative 3. So R1 which will come up again, is the 1 minus the negative 3. Any other questions? I'm doing because there's a bit of a lag in the chat again. So, okay, so let me erase. So let me do it about y equals 7. So again, we get the same picture to start. Getting worse at drawing. So there's the y equals 1 and the y equals 5 minus x squared. But now, and again, scale, here is y equals 7. And I'm going to rotate around. So there is on the other side, and again, I'm not going to make it three-dimensional, but so I'm going to get this. And again, if I do a cross section, it's going to look the same. It's still going to be a washer. But now, since this is the middle, the y equals 7, when I look at the radius, this will be my R1, and this will be my R2. And again, we'll have area is equal to pi r squared. And again now, so ask, why is the shape upside down? Because think about what we're doing is we're going to rotate this around the line y equals 7. So as I rotate it, it's going to flip. Whereas if you go back to the last one, if you rotate it around the x-axis, it will not flip. It'll flip in a different way. So it's kind of translating it above. So like the last one, we need what is R1, what is R2. In this case, R2 is the easy one, so let's start with that. So R2 is the distance from the line y equals 7 to the line, let me write it in here, y equals 1. So what is R2 here? And someone puts in 6. Yes, the 7 minus 1. And R1 is the distance from y equals 7 to the function, so therefore it is, and someone already put it in, sinus y, which is the 7 minus function. And once we have that, then it's the same as the last couple. Again, 0 to 2, because we haven't shifted where the function is. And pi of the bigger radius again, I won't simplify, but that is 2 plus x squared, quantity squared. And that, again, would be our answer. So any questions on this? Oh, so R1, let me make it more specific. R1 is the distance from y equals 7 to the top of the curve. And we know that distance between 2 points in one dimension is just the bigger point minus the smaller point, so the 7 minus the y. Any other questions? Now what I'm going to do is switch it. We've now done x-axis and something parallel, so what I want to do is go around the y-axis. And we'll see that in this case we can do it, but in general there might be a problem. So we're going to do it, get a different technique. So let me erase. I wait to make sure you don't have any quick questions. Okay. So there's our original space again. And now we're going to rotate it this way around the y-axis. That's supposed to be a dot line. So again, I'm not going to try to make the three-dimensional, but as I rotate it around, I'm going to get this three-dimensional object. And so now if I cut at a given x, I'm not going to get a, but if I cut at a particular y and rotate here, since there's no space in the middle, we're just going to get the circle. And you can see that for a given y, this is now x. And so there r will be equal to x. But that's in terms of a function. So what we have to do is, if we're going to use our same technique, is to take our, sorry, let me start again. Start with our function and solve for that in terms of x. So flip the x squared and the y, take the square root, and I get that. I'm only looking at this part in the first quadrant, so I don't have to worry about the plus or minus when I take this root. So I get that. And now here I'm doing it in terms of y's, so I need to remind myself that this is the point 0, 5. So I get the integral, sorry, that should be a 1. Integral from 1 to 5, y goes from 1, which is this line here, to the top at 5. Again, we're using our area is equal to pi r squared. Oops. That's supposed to be a dy. Sorry about that. So in this case, it's not too bad, but we do have to solve in terms of x. So same technique, but as in, oh, so someone asked where the 1 and the 5. So the 1 and the 5 are, since, let me rewrite that to make it more obvious. We're doing it with respect to y. So we need to know what is the smallest y. So if I look at my picture up here, it starts at y equals 1. And the top of the picture is here at y equals 5. So I have to look at it bottom and top instead of left and right like I did the last one. We're going to redo this where we don't have to worry about this. So if you don't like solving for y, ignore this. We'll do this a different way where you don't have to solve for y. So I do a quick thing to show that really we do need a different technique, which is suppose I had that y was equal to x e to the x. So someone asked a question, but let me do this and then I'll come back to the question. So the problem with this one is if I did around the y-axis and I went to solve for x in terms of y, well, I just can't do it, right? Because to get rid of, to solve for the x in the exponent, I have to take the natural log, but that would put the outside x in term inside the natural log. So this is not something I can easily solve, so I want a different technique. So I was asked about what happens if this extended into negative values for the function. And there are two things to talk about. So let me go to a new board before I redo this one. So kind of an aside here in a second. But so any questions on what I've written here before I erase? So I go back here and so asked about what happens if this was, oops. So suppose this was the starting value. And I asked what happens if it rotates around the y-axis. And you can see that what's going to happen is that we're going to duplicate stuff as we rotate around, because for this part, after I rotate by 180 degrees, I'll get this part. And so I'll start duplicating things. So instead of going all the way around, I might just do half of it. Or if I had something worse where it wasn't symmetric, I might have to do something else. And we're just not going to do ones where that comes up. On the other hand, if this is the region, so by the last one, I wouldn't rotate it around the y-axis because that would be complicated. Can anyone hear me now? Okay, so it turns out that putting in the speaker and then taking it out will sometimes help. So as I said, we'll figure it out. So here's again their same picture. But what I'm going to do is instead look at it from above. So this is what it's going to look like from above. And what I'm going to do and my circles are lovely. Break it up by making little slices. So I'm going to start in the middle, make a little slice, and let's take this slice. I'm then going to pull it out. And I'm going to get a very thin little cylinder. So inside this is empty. So it's just the one little piece. So I'm going to take a piece from the middle, take another piece just outside of it, take another piece just outside of it, and keep going until I get to the end. And then I'll do the usual integral thing, which is let the width of the pieces get smaller and smaller, and look at the sum. So here's my slice from there. If I unroll it, I get this, where it's very thin. So I'll put in a little thinness here, but this thinness will become our delta x, which means it'll be the dx. And so you can see, here's the height in here, here's the height. If this is the radius, then what is so you can see I get a rectangle. Then what is the length? It's the perimeter of the circle, so it's 2 pi r. So let me go back to my picture. So this is from above. This slice in our picture up here will be right here at x. And this is going to be our little cylinder. So this and this are the same cylinders, just in context. So you can see, what is our r? is going to be x. And looking at our picture, what is our height? So y, but not quite, because it's y and then minus the 1. So therefore, we're going to get our area, except not cross-sectional, but our area of our little slice. So this will be called cylindrical shells, will be 2 pi RH, which from what we just said will be 2 pi x our y minus the 1. And then we sum it over all the possible x's. Notice that limits for the x's is the same as the other one. So that will be the difference. So this is cylindrical shells. And the nice thing about it is, even though we're rotating around the y-axis, we do not have to rewrite it in terms of x. So we can leave it as y as a function of x. So obviously we have to do more of these examples. But let me take the same one, do the same thing we did. So yes, this is the shell method. So let me do another one. Here we did it around the y-axis. You're going to tell me what changes if I rotate it around something different. So I just do one more example since we're fairly close. So enter the questions before I erase. This one, obviously, I have to do more examples. Okay. So this was, we did about the y-axis. I forget what we're up to, E, I think. So let's do about x equals -3. So this one I will try to show the slice. So sorry about my graphing ability. So here's my slice at x. Here it is after I've rotated it. And now I'm going to get this as my little piece. So if you compare this to the last one, we still are getting a little cylinder that's really thin. And so the question is, again, what is R and what is H? So let's start with what will be the easy one. What is H? So let me make that right. So the same as the last one. So notice the height has changed. The fact that we're rotating it from further away hasn't changed how tall the piece is. So it's still y equals y minus 1. On the other hand, obviously, the radius has changed because we're going from further away. So now that I've drawn it, it should be obvious. What is R now? So x plus 3, 3 plus x, right? So we get, again, integral 0 to 2. Notice for all these, since the original region is from x equals 0 to 2, all our integrals go from 0 to 2. And we again have the 2 pi. Remember that x is the radius, so that's going to change. Oops, I'm not sure why I wrote 2. X plus 3. And the height is the same, so it's still the y minus 1, so still the pi minus x squared minus 1, just like the last one. So any questions on this? So to give a chance for people to ask more specific questions, and because we probably all have a class at 10:30, it takes a little while to transition. Let me stop here. For tomorrow, we'll try the homework in 3. The next topic we'll do is 3.7, which is mass and density. And that will turn out to be fairly easy. Also, a separate thing, since we had these disruptions, officially our schedule, our syllabus goes through the chapter 3 material and then into the chapter 1 material in the new text. Because of the disruptions, we will try to get through into chapter 1, because that is also in calculus 3 if you move on, but it will not be on the final. So the last couple classes will be going over material that is really just for you if you're going to Cal Ready. So you will not have to worry about any of the material from chapter 1 in the new text, the multivariable text, for the final. So I will stick around in here for a little while, so if you have any questions, otherwise we are done for the class, so I'm going to, after a minute, stop. As I said, as the last one, I will probably this afternoon put this up on Blackboard, not on Blackboard, on YouTube. Oh, and you'll see, if you go to the notes on Blackboard, you'll see we didn't get quite as far as my notes, so we'll finish that tomorrow. See you tomorrow. So a couple quick questions. So someone asked, oh, so is the integral you have on the screen just the volume of the rotate? Yes. Right, so that is the volume of the rotated cylinder. So this thing here is the volume of the rotated cylinder. Any other questions? Okay, I'm going to stop the recording.